A sequence has terms a1, a2, a3, dot, dot, dot. The first term is a1 equals x, and the third term is a3 equals y. The terms of the sequence have the property that every term after the first term is equal to 1 less than the sum of the terms immediately before it and after it. That is, when n is greater than or equal to 1, an plus 1 is equal to an plus 1 minus 1. The sum of the first 2018 terms of the sequence is a1, they told me, is x. a3, they told me, is y. So our job is to figure out the rest. First, let's just figure out a2. So a2, it looks like, is equal to a1 plus a3 minus 1. So that's going to be x plus y minus 1. So let's put that here. Now we have to figure out a4 and so on. And my hope is that there's going to be some sort of pattern, and that pattern will help us figure out what is the sum of the first 2018 terms. So let's use that recursive formula, but I think it's easier if you rearrange it in terms of an plus 2 and what that is equal to, which would be an plus 1 minus an plus 1. Okay, so using that, a4 would be y minus x minus y plus 1 plus 1. So that is 2 minus x. Okay, so put that here, 2 minus x. a5 would be 2 minus x minus y plus 1. So that looks like 3 minus x minus y. Okay, let's try a6. a6 looks like 3 minus x minus y minus 2 plus x plus 1. So that's 1 and then minus 2. If you add up all the numbers, minus y, because the x's cancel. Okay, 2 minus y. Let's keep going here. a7 would be 2 minus y minus 3 plus x plus y plus 1. And that looks like the y's cancel. So I have just x because the numbers cancel. Okay, we got x here. Let's see what happens with a8. So a8 would be x minus 2 plus y plus 1, and that is equal to x plus y minus 1. Okay, great. And I'll just do one more, a9. And let's see what a9 is. I'll do it up here. a9 would be x plus y minus 1 minus x plus 1, and that gives me just y. Okay, so I got it. So there's a repeating pattern every 6, as you can see. And I'm pretty confident that a10 would be 2 minus x, and you can do it, of course. a11 would be 3 minus x minus y, and a12 would be 2 minus y, and so on. So every 6, it repeats. So what we need to do is figure out what that sum is of those 6. So let's see here. 1, 2, 3, 4. Oh, the x's cancel. Y minus y minus y. The y's cancel. So I just have numbers 2, 3, 2. So that's 1, 2, 3, 4, 5, 6, 7 minus 1, 6. So the sum of those 6 is 6. And we have 2018. So let's see, does 2018 factor evenly, does it divide by 6? And the answer is no. It's 336, but it gives a remainder of 2. Okay, no problem. So that means we've got 336 of these sets of 6. And each set of 6 has a sum of 6. So multiply that by 6. And then we have to add 2 more. So we have to add this guy and this guy. The next 2. So that would be x plus y minus 1. So 336 times 6, 2016, plus 2x plus y minus 1. And that's going to be 2015 plus 2x plus y. 2015 plus 2x plus y, and that is choice E for number 21. Every 12 minutes, bus A completes a trip from P to X to S to X to P. Every 20 minutes, bus P completes a trip from Q to X to T to X to Q. Every 28 minutes, bus C completes a trip from R to X to U to X to R. At 1 p.m., bus A, B, C depart PQR respectively, each driving at a constant speed and turning around instantly at the end point of its route. Each bus runs until 11 p.m. At how many times between 5 and 10 p.m. will 2 or more buses arrive at X at the same time? Well, we need to make a table. And let's first talk about this. So our starting point is 1 p.m. And that's where we have P. And then I'm just going to write the numbers, make it a little bit faster. So at exactly 3 minutes later, it'll be at X, then 3 minutes later at S, then 3 minutes later at X again, and then finally at 3 minutes later back at P. In 12 minutes, it makes that journey. And in a very similar way, if you keep going 15, 18, 21, and 24, it would again be X, S, X, P. So obviously, it's at X at these times. And as you can clearly see, it starts at 3, but every 6 minutes it's back at X. In a very similar way, we'll do the story for bus B. It starts at 1 p.m. and it is originally at Q. And then every, let's see here, 20 minutes, so you got to divide that by 4. So every 5 minutes, so 5, 10, 15, and 20 is where it meets at X, T, X, and then back at Q again. And in a very similar way, every 5 minutes after that, 25, 30, 35, and 40, it would be at XT, XQ, XT, XQ, like that. So here, as you can clearly see, you start at 5 minutes, but then every 10 minutes after that, you're going to be back at X. Same story for C, slightly different numbers though. This time it's R, XU, XR. And then it's 28 minutes every 7 minutes. So 7, 14, 21, 28 is your R, XU, XR. And then 35, 42, 49, and 56. XU, XR. Like that. All right, so that means every 7 minutes, it starts at 7, but then every 14 minutes, it's going to be at X. All right, so we have covered that. Now, it starts at 1, and then we want between 5 and 10. So just be careful here. It starts at 1 p.m., and I'm going to convert everything to minutes to make it easier. 5 p.m. is 4 hours later. So write that here. 5 p.m. is 4 hours later. So 4 times 60 is 240 minutes. So this is where it begins in terms of where we want to look at when they meet. Between. And then 10 p.m., that compared to 1 p.m. is 9 hours later, right? And 9 hours is 9 times 60, which is 540. Like that. So we want to look at times in between 240 and 540. Okay. Well, at this point, you're just adding 6 every time. So if you just kept adding 6 to 21, actually adding 6 to 3, really, that's the starting point. You eventually get to where we are. And the first time you get above 240 is 243. And then 249, you're just adding 6 every time, ... You just keep adding 6 every time, and then you eventually get to 537. That's the last time before 540, which represents our 10 p.m. So you can make a little formula. It's really 243 plus 6K. And that's a pretty straightforward formula. So same thing here. We want between 240 and 540 minutes. You're starting with 5 and you're adding 10 each time. So the first time you get above 245 is, the first time you get above 240 is 245. And then you're adding 10 each time, so 255, dot, dot, dot. And then eventually you get to 535, which is the last time before 540, which is 10 p.m. So this formula is 245 plus 10K, or 10M. Let's use different letters because it's not necessarily going to be the same value. Okay, by now I think you're an expert. This is 240. This is 540. You are starting at 7. You're adding 14 each time. And then when you keep doing that, eventually you get to 245 as the first time, and then 259 because you're adding 14 every time, and then dot, dot, dot. And then eventually you get to 539. So right before our 10 p.m. cutoff. And this one is what? 245 plus 14N. All right, so we have established that. So the question basically boils down to saying, when do we have 243 plus 6K, which is bus A, equal to bus B, which is 245 plus 10M? Also, the question is saying, when is bus B equal to bus C, which would be 245 plus 10M is equal to 245 plus 14N. And then one final comparison would be A equal to C, and that would be 243 plus 6K is equal to 245 plus 14N. All right, so let's do those three, and that should be sufficient to figure out our answer. All right, so here we go. The first one, this one right here, that one gives us, let's see here, 6K minus 10M is equal to 2. Divide through by 2, and I get 3K minus 5M is equal to 1. So now I'll make a little table, K and M, and try to get integer solutions. So start plugging away, and 2 and 1, that will work. 7 and 4, 12, and 7, and so on. You can pretty much get a very quick pattern. It looks like it goes up by 5, so 17, 22, 27, 32, 37, 42, 47. And then I'm going to put the time, because the time's important. So for example, when K is 2 and M is 1, when K is 2 and you plug it into there, you get 242 plus 12, which is 255. So I'm going to put the time here. Actually, it's not 255 in terms of the time, like 2 hours and 55 minutes. It's 255 minutes. So I just want to make that clarification. Okay, very similarly, you do the same thing, and you get 285, 315. These are minutes, of course, 345 minutes from this 1 p.m. Let's see here. I'm just got to make this match here. 375, 405, 435, 465. Are we adding 30 every time? Yeah, I could have just added 30 every time. 495 and then 525. Okay. So how many did I get? Because if I go another 30, I'll be at 555, and that goes above my boundary, which was 540. So I got to stop at 525. All right, so how many did I get here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 10 times that bus A meets bus B. So let's now go to bus C and B. So this gives me 245. Oh, those cancel. So it's just 10M is equal to 14N. Okay, and then I guess I can divide through by 2. 5M is equal to 7N. So again, make a little table, and off we go. So it looks like the first solution is 0 and 0. That's helpful. And then 7 and 5. And then I think just multiples, so 14 and 10, 21 and 15, 28 and 20, And then after that, I think it'll be above the 540. Let's just write out our times. This one is just 245. When m is 7, and we put in there, it's going to be 70 plus 245, which is 315. And then I think I'm adding 70 each time. So 385, 455, and then 525. And then that's basically at the cutoff, because the cutoff is 540. So here I got 5. But we got to eliminate doubles. That's the key to this question, in my opinion. 315 has already been counted, and so has 525. So 315 here, I cannot count again as a unique spot or time. So I only really have 3 new ones. So I got to put that here, only 3 new. So these 3 are the ones that I'm going to count in my cumulative total. All right, one last one. This one gives me 6k. Let's see here, 6k minus 14n is equal to 2. That means 3k minus 7n is equal to 1. All right, same thing here. We've got to make a little table, and off we go. So we get integer solutions as following. 5 and 2, 12 and 5, 19 and 8, and I think it goes up by 7 each time. So 26, 33, 40, 47. And I think after that we meet the cutoff. So the times, plugging back into here, for k is 5, it'll be 243 plus 30, which is 273. And then same thing, 315, 357. It looks like I'm adding a certain, 42 I think I'm adding every time. Yeah, I think so. And then 399, 441, 483, and then 525. And then if I add another 42, I'll go over that 540 boundary. Okay, so I got 7 here, but again, 315 and 525 are already counted, so I already got 5 new. All right, so now I'm ready to add my total. 10, 3, and 5. So that is 18. So 18 times those buses will meet, and therefore number 25, the answer is A. This expression is equal to, all right, so 1 plus a half, when you do that, it's 3 over 2. 1 plus a third, that's 4 over 3. 1 plus a quarter, 5 over 4. 1 plus a fifth, 6 over 5. 1 plus a sixth, 7 over 6. 1 plus a seventh, 8 over 7. 1 plus an eighth, 9 over 8. And finally, 1 plus a ninth is 10 over 9. And then these 3's cancel, these 4's cancel, 5's cancel, 6's cancel, 7's cancels, 8 cancels, 9 cancels. The only thing you're left with is 10 over 2. And 10 over 2 is equal to 5. So, pretty cool question. Number 14, the answer is A. An 8 by 8 by n rectangular prism is made up from 1 by 1 by 1 cubes. Suppose that A is the surface area of the prism and B is the combined surface area of the 1 by 1 by 1 cubes that make up the prism. What is the sum of the values of n for which B over A is an integer? I will first start off with a simple example. Let's say n is 2. And hopefully this example will make you understand how to approach this question. So in this case, if n is 2, it will be an 8 by 8 by 2 dimension rectangular prism. And that area is 128. Now it's made up of these unit cubes. Each has an area of 1. So it'll be 128 unit cubes in this scenario. Now the surface area, which they are calling A, of the prism will be as follows. It'll be 2 times 8 by 8 plus 2 times 8 by 2 plus 2 times 8 by 2. So I just drew what it could look like, that prism. Okay, so let's figure this out now. This would be, in terms of numbers, 192. Now let's figure out B, which they are calling the combined surface area of the unit cubes. Well, there's 128 of them, and each of them would have a surface area of 6, since it's just basically a unit cube with each side being 1 by 1. So there you go. So that would mean 128 times 6 is 768. So what is B over A in this case? B over A would be 768 over 192, and that is 4. Is that an integer? Yes. So that is how we approach this question. Now let's do the exact same thing, but instead of n being 2, n is just n. So now we have 8 by 8 by n, and that is 64n. That is the number of unit cubes that make up this particular prism. Our surface area of the cube would be 2 times, again, 8 times 8. That's the bottom of the base of the prism. Then it would be 2 times 8 times n this time, plus 2 times 8 times n. So this is 128 plus 32n. Okay. Now B, well, that's very easy. That's just going to be the number of unit cubes, which is 64n, times 6, which is just 384n. Okay, so now what is my B over A? It is 384n over 128 plus 32n. I think I can divide through by 32, and when I do, I get 12n over 4 plus n. All right, so this is very, very nice. I think I can work with this without too much problem. I've got to start plugging in values of n so that this becomes an integer. Okay, I'm sure I can do that. Let's make a table and proceed. So we got n, and then we have 12n over 4 plus n. So this is, at this point, just plug and play. Let's try 1. When you get 1 for n, you get 12 over 5. Is 12 over 5 an integer? No. You try 2. That's 24 over 6, and that is an integer because that is equal to 6. So we circle that. That was actually the one I did in the example. I used n equals 2. So we know that's going to be an integer. And you just keep going like this. 3, and it's going to be 36 over 7. That's not an integer. And then 4. 4 is 48 over 8, and that is an integer. It is equal to 6. So circle 4 as a value for n. And you just keep going like this. So I'm not going to bore you by going through every single one. I'm just going to write the ones for which this becomes an integer. And it is time consuming, but that's the way it is since it's number 25. 8 works. It gives you 96 over 12, which is equal to 8. And therefore, that works in terms of giving you an integer value. The next one that works is 12 for the value of n. It gives you 144 over 16, which is equal to 9. 9 is, of course, an integer. The next one that works after a lot of numbers that don't work is 20. You have to get all the way up to 20. 240 over 24, and that's 10. And then you get really painful. You've got to keep trying until 44 to get the next value of n. And that gives me a integer value of 11. And at that point, it's finished, thankfully. And now you just have to add up the values of n that worked. So 2 plus 4 plus 8 plus 12 plus 20 plus 44, and that's 90. So that is the answer, and that's B. Now you might say, well, how do you know that you have to stop at 44? Why didn't you just keep going here, 45, 46, and so on? Because if I did, my sum would be greater than 90. It would be much greater than 90. It would be at least 45 greater than 90, and there's no answer choice that is that big. So you can be confident that 90 is indeed the right answer. So number 25, that would be B. In each row of the table, the sum of the first two numbers equals the third number. Also, in each column of the table, the sum of the first two numbers equals the third number. What is the sum of the 9 numbers in the table? So, they've told you that this equals this and that equals that, pretty much, if you read the opening stem. So that means that m plus 8 plus 4 plus n is equal to 6. And that means that m plus n is equal to minus 6, right? 6 minus 12. And if you do that part, it's exactly the same. So it doesn't give you any different result. So now let's just jump to what they want, the sum of the 9 numbers. So let's add up all these 9 guys. So that's going to be, let's see here, m plus 4 plus m plus 4 plus 8 plus n plus 8 plus n plus m plus 8 plus 4 plus n plus 6. And if you add up all these guys, you get 3m plus 42 plus 3n. Factor out the 3, and that will give you m plus n plus 42. And the good news is that m plus n, we just figured out, was minus 6. So there you go. And that's going to be negative 18 plus 42, and that is equal to 24. So number 21, the answer is E.